July 14th, 1944, 3 miles southwest of Saint-Lô, France. Lieutenant General Omar Bradley stood with his arms crossed, watching a Sherman tank reverse away from a hedgerow that had stopped American advances, cold, for 6 weeks. Around him stood a small group of officers, including Major General Leonard Gerow, commander of 5th Corps, and several ordnance specialists who had been summoned to witness what might be either a breakthrough or another failed experiment. Welded to the front of the tank were 4 steel prongs that jutted forward like tusks, a contraption so simple that Bradley had initially dismissed the report when it first crossed his desk. But desperate times demanded desperate measures, and the American breakout from Normandy hung in the balance. The tank's engine roared to life. The driver shifted into gear and accelerated directly at the ancient earthen wall, 10 miles per hour. 15. The steel prongs struck the hedgerow with a sound like tearing canvas, a noise that would become familiar to American tankers across France in the coming weeks. Earth and roots exploded upward in a fountain of dirt. The tank did not climb or tilt. It drove straight through, its prongs cutting into the base of the hedgerow like enormous knives through tough fabric. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. And then, in less than 5 seconds, the Sherman burst through to the other side, trailing broken branches and torn vegetation, but otherwise undamaged, its belly armor never exposed to enemy fire. Bradley's staff officers erupted in cheers. Ordnance specialists scrambled to examine the hedgerow, measuring the breach, checking for damage to the tank. The general himself remained silent for a moment, his mind already calculating the implications. If this device worked reliably, if it could be manufactured in quantity, if it could be installed on enough tanks before the planned offensive, then perhaps Operation Cobra could succeed. Perhaps the stalemate could be broken. He turned to Lieutenant Colonel John Madaris, his chief ordnance officer, and spoke words that would change the course of the war. "I want these devices manufactured and fitted to as many tanks as possible. Every Sherman, every Stuart, every tank destroyer we can modify. I want them ready before Operation Cobra launches. Round-the-clock production. Use every ordnance unit, every maintenance depot, every welder we have. This is top priority." What Bradley had just witnessed was the solution to a problem that had threatened to turn the greatest amphibious invasion in history into a bloody stalemate. For 6 weeks, the bocage of Normandy had defeated the most powerful army ever assembled. The hedgerows, ancient boundaries between Norman fields, had proven more formidable than German concrete fortifications, more effective than minefields, more deadly than the Atlantic Wall itself. And the man who had solved this seemingly impossible problem was not a general with decades of military experience, not an MIT-trained engineer with advanced degrees, but a 29-year-old sergeant from New Jersey who had improvised a solution from scrap metal salvaged from German beach obstacles and applied nothing more complicated than common sense and a welding torch. This is the story of how Curtis Cullen's simple welding trick broke the Normandy stalemate and opened the road to Germany. But to understand the magnitude of what Cullen achieved, we must first understand the nightmare that American forces faced when they pushed inland from the beaches of Normandy in June 1944, 300 meters away. Supreme Commander Dwight David Eisenhower paced in his headquarters at Southwick House, near Portsmouth, studying maps that told a story of mounting disaster. It was mid-June 1944. The D-Day landings executed just days earlier had succeeded beyond even the most optimistic projections. Despite horrific casualties on Omaha Beach, where American forces had nearly been thrown back into the sea, by nightfall of June 6th, more than 150,000 American, British, and Canadian troops had established footholds along 50 miles of French coastline. Within a week, the Allies had landed over 300,000 troops and established a continuous beachhead from the Cotentin Peninsula to Caen. The greatest amphibious assault in history had breached Hitler's Atlantic Wall. The fortress Europe that Nazi propaganda had declared impregnable had been penetrated. But the maps told a darker story. Yes, the landings had succeeded, the beaches were secure, Supplies were flowing ashore through the two Mulberry artificial harbors and directly over the beaches. But the advance inland, the rapid exploitation that was supposed to carry Allied armies deep into France, had stalled almost immediately. By mid-June, 2 weeks after D-Day, Allied forces controlled a beachhead barely 20 miles deep and 50 miles wide. More than 1 million troops were now ashore, but they were wedged into a narrow coastal strip, unable to advance, bleeding casualties by the thousands every day, and facing the very real possibility that the entire invasion might collapse into the same kind of static trench warfare that had characterized World War I. The grand strategy, carefully developed over 2 years of planning, called for rapid breakout from the beachhead. British and Canadian forces would seize Caen, a critical road and rail junction, on D-Day itself, and push south into open tank country. American forces would cut across the Cotentin Peninsula, capture the port of Cherbourg within 9 days, then wheel south toward Brittany. Within 2 weeks, the Allied penetration was supposed to extend 15 miles inland, along a continuous front, mobile warfare, rapid exploitation, armored thrusts deep into German rear areas. This was the vision that had guided planning. Instead, the Allies were bogged down in brutal close-quarter combat, advancing by yards rather than miles, losing thousands of men for tiny gains in territory. And the reason had a name: the bocage, the hedgerows of Normandy. June 7th, 1944, 24 hours after the successful landing on Omaha Beach, soldiers of the 1st Infantry Division, the Big Red One, pushed inland from the coast. They were exhausted from the beach assault, having suffered nearly 2,000 casualties in the landing, but they were alive, and they had broken through the Atlantic Wall. They expected to encounter retreating German forces, perhaps some hastily prepared defensive positions in the villages and towns inland. What they found instead was a landscape that seemed designed by nature itself to favor defenders and destroy attackers, a green maze that would prove more deadly than the German fortifications they had just overcome. Private James Henderson of the 26th Infantry Regiment wrote in his diary that first day a passage that would be discovered decades later in the National Archives. "We thought we were through the worst after the beach. We had beaten the Atlantic Wall. We had survived the worst that Hitler could throw at us. Then we came to these hedges, these damned Norman hedges. God help us all." The hedgerows were not hedges in any sense that American soldiers understood. They were not like the decorative shrub borders that Americans knew from suburban yards back home. They were not agricultural fencing that could be cut or pushed aside. They were ancient fortifications built up over centuries by Norman farmers who had shaped this landscape since the Middle Ages. The process had begun 1,000 years earlier, when farmers cleared their fields of stones and rocks, piling them along property boundaries to mark ownership and create barriers for livestock. Generation after generation had added to these walls. More stones, more earth. Seeds from plants growing on top would fall and take root. Trees would sprout. Over centuries, the walls grew into earthen banks 3 to 12 feet high and 1 to 10 feet thick at the base. The soil composing these banks was packed hard as concrete, compacted by centuries of settling and reinforced by the root systems of the vegetation growing on top. On these earthen ramparts grew oak trees, hawthorn bushes, brambles, wild roses, and thorns that intertwined into barriers that rose 15 feet above the earthen base. The roots penetrated deep into the banks, some extending 10 or 15 feet down through the packed earth, creating a reinforced structure that was stronger than most man-made fortifications. These root systems were so dense, so thoroughly intertwined after centuries of growth, that the hedgerows could not be dug through without power tools and could not be blown apart without massive explosive charges that would reveal American positions to every German within miles. These hedgerows surrounded irregular fields that varied wildly in size, but averaged 200 to 400 yards across. Some fields were nearly square, others were long and narrow, some were triangular. The pattern was completely irregular, the product of 1,000 years of inheritance law, land division, and agricultural practice. Aerial photographs taken by reconnaissance aircraft in the weeks before D-Day had revealed the true scope of the problem, though intelligence officers had failed to appreciate its tactical significance. One photograph of the American sector, covering just 8 square miles, near Saint-Lô showed nearly 4,000 separate hedge-enclosed fields. Each field was a potential fortress. Each hedgerow formed a defensive wall, and there were thousands of them stretching across the entire American sector, from the coast to the base of the Cotentin Peninsula and south toward Saint-Lô. For German defenders, every hedgerow was a ready-made defensive position superior to anything military engineers could construct. Machine gun teams could dig firing positions into the earthen banks, creating small apertures just large enough for the gun barrel that overlooked the open fields. These positions were invisible from more than a few yards away, protected from artillery by the earthen bank itself, immune to everything except a direct hit by a large-caliber shell. The vegetation on top provided perfect concealment from aerial observation. Spotter planes flying overhead saw only an unbroken canopy of green. The thick earthen banks protected soldiers from shell fragments and small arms fire. A German soldier crouched behind a hedgerow was safer than a soldier in a concrete pillbox because the pillbox could be identified and targeted while the hedgerow position was invisible until it opened fire. The tactical advantages for defenders were overwhelming. A single German squad, 8 or 9 men, properly positioned behind a hedgerow with a machine gun and rifles, could cover an entire field and hold off an American company of 200 men for hours. The Germans did not need continuous defensive lines. They did not need to man every hedgerow. They simply positioned small groups throughout the bocage, creating a defense in depth where each position supported the others. When American forces attacked across a field, they faced fire not just from the hedgerow directly in front of them, but from hedgerows on their flanks, creating a crossfire that turned every field into a killing zone. American attackers faced tactical problems that were almost impossible to solve with available resources and doctrine. Infantry attempting to cross the open fields were completely exposed. There was no cover in the middle of a Norman field, no trees, no rocks, no depressions in the ground, just open grass or crops with German machine guns and rifles covering every square yard from positions that could not be seen until they opened fire. The Germans had already registered their weapons on likely crossing points, marking ranges, calculating angles, preparing to deliver fire the instant American troops emerged from the previous hedgerow. Making the approach to the next hedgerow was a journey through pre-targeted killing zones where German gunners did not need to aim. They simply fired at predetermined points and hit whatever was there. The sunken lanes that connected the fields, worn deep into the earth by centuries of cart traffic, were equally deadly. These narrow passages, some barely wide enough for a single vehicle, were obvious routes for American advance and, therefore, obvious places for German ambush. The Germans would block the lanes with felled trees, rubble from destroyed carts, or simple piles of earth. Then they would position machine guns to cover the obstacles from concealed positions. American troops attempting to clear these lanes were channeled into narrow defiles where a single machine gun could stop an entire platoon. And American tanks, the Sherman medium tanks that were supposed to be the key to mobile warfare and rapid exploitation, were neutralized completely by the bocage. The Sherman was a good tank by any reasonable standard. Its 75mm gun could destroy any German tank at normal combat ranges. It was reliable, easy to maintain, and produced in quantities that German industry could not match. American factories were building Shermans at a rate of more than 1,000 per month, but all these advantages meant nothing in the bocage, because Sherman tanks could not penetrate the hedgerows. The earthen banks were too thick, too solid, too heavily reinforced by root systems. A Sherman's 75mm gun could blow a hole in the vegetation on top, but that did not create a breach large enough for the tank to pass through. The earthen base remained intact. Tank commanders, frustrated and desperate, began attempting to breach obstacles by brute force. They would back up to get a running start, then accelerate directly at the hedgerow, attempting to use the tank's weight and power to smash through or climb over. This tactic was suicidal. When a Sherman attempted to ride up and over a hedgerow, the front of the tank would rise as it climbed the earthen bank. The tank would tilt backward at an angle of 30 or 40 degrees. This exposed the belly of the tank, the underside between the tracks, which was protected by only 1 inch of steel armor. This armor was designed merely to resist mine fragments, not to stop anti-tank weapons. A German soldier with a Panzerfaust, the shoulder-fired anti-tank rocket that was issued to German infantry by the thousands, could position himself in the next field and simply wait. He would hear the tank engine roaring as the Sherman climbed the hedgerow. He would see the front of the tank rise above the vegetation, and when the belly armor was exposed, he would fire. 1 rocket was usually sufficient. The Panzerfaust could penetrate nearly 6 inches of armor. Against the Sherman's 1-inch belly plate, it was devastatingly effective. Lieutenant Colonel Wesley Yale, commanding a tank battalion in the 2nd Armored Division, lost 4 Sherman tanks in a single morning attempting to breach hedgerows near the town of Isigny. 4 tanks destroyed, 4 crews killed or wounded, 16 men dead or injured, and not a single successful breach. His after-action report, filed on June 15th, captured the frustration and rage felt by every American armor officer in Normandy. The enemy need not even see our tanks to destroy them. They position themselves in the next field behind the next hedgerow and simply wait. They listen for the sound of our engines. They hear us climbing the obstacle. And when we reach the top, when our belly is exposed, they fire. We are losing crews and machines to an enemy we never see, never engage, never have a chance to fight. Our tanks, which should be our greatest advantage, have become death traps in this cursed country. American forces tried every solution their training and doctrine suggested. Combat engineers trained in demolitions and obstacle clearance were brought forward to blow gaps in the hedgerows using explosives. This technique worked technically. A properly placed charge of TNT or Composition C could blast a hole through even the thickest hedgerow, creating an opening large enough for a Sherman to pass through. But the tactic had fatal flaws. First, it was slow. Engineers had to move forward under fire, approach the hedgerow, place the charges, connect the detonators, retreat to a safe distance, and blow the charge. This process took 10 to 15 minutes under ideal conditions, longer under fire. Second, the explosions announced American intentions to every German within hearing, which in the relatively quiet Norman countryside meant every German within 2 or 3 miles. Enemy machine gunners and mortar teams would train their weapons on the gap before the smoke cleared. Third, American infantry and tanks advancing through these blown breaches were funneled into a single narrow opening that became a pre-targeted killing zone. German gunners did not need to search for targets. They simply fired at the gap and hit whatever came through. Specialized armored vehicles, particularly bulldozer tanks, proved little better. These were standard Sherman tanks fitted with heavy steel bulldozer blades on the front, designed originally for clearing beach obstacles during amphibious landings. In theory, these vehicles could push through or scrape aside the hedgerows, creating passages for following tanks. In practice, they became priority targets for German anti-tank gunners. The bulldozer tanks were slower than standard Shermans, less maneuverable, and highly conspicuous. German observers would identify them immediately and direct anti-tank fire at them, knowing that destroying the bulldozers would deny the Americans their primary means of breaching obstacles. The 2nd Armored Division, which had landed in Normandy with 14 bulldozer tanks, lost 11 of them in the first 3 weeks of combat. By early July, American forces had virtually no bulldozer capacity left, and the few surviving vehicles were being hoarded for critical missions rather than routine hedgerow clearing. By late June 1944, 6 weeks after D-Day, the American advance had slowed to a nightmarish crawl, measured not in miles per day, but in yards per hour. The human cost was staggering and unsustainable. Official United States Army histories document that 8th Corps, advancing through the bocage toward La Haye-du-Puits and Saint-Lô, suffered over 10,000 casualties while advancing approximately 7 miles. Some secondary sources have cited figures approaching 1,000 killed per kilometer for portions of this advance, though these specific numbers are difficult to verify from official records. What is certain is that American infantry was dying at rates that rivaled or exceeded the worst battles of World War I. The capture of Montcastre, a hill overlooking the Cotentin Peninsula, cost American forces approximately 2,000 casualties in brutal close-quarters fighting. The 1st Infantry Division, which had landed on Omaha Beach on D-Day, lost 75% of its frontline infantry in the first month of combat. Companies that had landed with 150 men were down to 30 or 40 effectives. The 29th Division suffered equally catastrophic losses. This was not mobile warfare. This was not the rapid exploitation that Allied planners had envisioned. This was attritional combat where every field had to be fought for, every hedgerow assaulted, every few hundred yards of ground purchased with American blood. And America, for all its industrial might and manpower reserves, could not sustain these casualty rates indefinitely. The replacement system was already strained. New soldiers arriving in Normandy were being rushed into combat with minimal training, thrown into veteran units to fill the gaps left by dead and wounded. Morale, which had been high after the successful D-Day landings, was declining rapidly. Soldiers who had survived the beach assault and thought they had faced the worst the war could offer were being broken by the grinding brutality of hedgerow combat. Officers at every level understood that something had to change, or the entire Normandy campaign would grind to a halt in a stalemate that could last months or even years. General Omar Nelson Bradley, commander of the 1st United States Army, faced a crisis that threatened not just his personal reputation, but the entire strategic plan for the invasion of Europe. His forces were exhausted, demoralized, and bleeding irreplaceable infantrymen at rates that could not be sustained. The British and Canadian forces to the east, fighting around the city of Caen, were making equally limited progress against heavy German armor. Field Marshal Montgomery's plan to seize Caen on D-Day had failed completely. The city would not fall until mid-July, more than a month behind schedule. The grand strategy that had guided 2 years of planning, the vision of rapid breakout and mobile warfare across France, was collapsing into the same kind of static trench warfare that had characterized the Western Front in World War I. Bradley's Chief of Staff, Major General Walter Bedell Smith, who also served as Eisenhower's Chief of Staff at Supreme Headquarters, described the situation in blunt terms that captured the growing sense of crisis. In a memorandum to Eisenhower, he wrote that every small field was a fortress, every hedgerow a German strongpoint. We are fighting World War I again, but this time the trenches are green and growing. Our advantages in mobility, armor, and firepower are negated by terrain. The Germans are trading space for casualties, and they are winning that exchange. Into this desperate situation, where the entire Normandy campaign teetered on the edge of failure, where American casualties mounted by the thousands and no solution seemed possible, came an ordinary soldier with an extraordinary idea. Curtis Grubb, Culin III, was 29 years old in the summer of 1944, a sergeant serving with the 102nd Cavalry Reconnaissance Squadron, which was part of the 102nd Cavalry Group operating under the command of 5th Corps. He was nobody special in the vast hierarchy of the American Army. He held no advanced degrees. He had no engineering training. His background was utterly ordinary, the kind of American biography that was repeated millions of times across the armed forces. Culin was from Cranford, New Jersey, a small town about 15 miles west of New York City. His father worked as a salesman for a liquor distributor. Curtis had attended local public schools, graduating from Cranford High School in 1935. He had worked before the war as a sales promotion assistant for Shenley Industries, the same liquor company that employed his father. When the war came, he had enlisted in the New Jersey National Guard and been mobilized with his unit. He was trained as a tanker and driver. He knew how to maintain and operate a Sherman tank. He knew how to fight in armored combat, but he had no special technical expertise that would suggest he was about to solve a problem that had baffled the best minds in the American military establishment. What Curtis Culin had was something that could not be taught in any school or acquired through formal training. He had practical American ingenuity, the kind of problem-solving ability that came from growing up during the Great Depression, when money was scarce, and you learned to fix things yourself, to make do with whatever materials were available, to improvise solutions rather than waiting for someone else to solve your problems. This was a particularly American trait, born of a culture that valued individual initiative and practical results over formal credentials and theoretical knowledge. It was the same spirit that had driven American inventors and innovators for generations, from Benjamin Franklin experimenting with electricity to the Wright brothers building an airplane in a bicycle shop. In early July 1944, during a brief respite from combat operations, soldiers from Cullen's unit gathered in an informal group to discuss the hedgerow problem. This was not an official meeting or planning session. It was just soldiers talking, sharing frustrations, venting anger about their situation. Tank crews, infantry, and officers all contributed to the conversation. They talked about friends who had been killed or wounded. They talked about tanks that had been destroyed attempting to breach hedgerows. They shared ideas, most of them impractical or impossible, about how to solve the problem. At some point in this discussion, a soldier from Tennessee made a suggestion that sounded to most of the group like a joke, or perhaps the ramblings of a man driven half-mad by combat stress. Military historian Max Hastings, in his book Overlord, D-Day and the Battle for Normandy, published in 1984, identifies this soldier only as a Tennessee hillbilly named Roberts. Hastings provides no first name, no rank, no unit designation, no documentation. Despite extensive research by military historians in the decades since, no primary source has ever been found that verifies this man's identity or even confirms his existence. The account rests entirely on Hastings's single mention, possibly based on oral history or anecdotal information that cannot be verified. Nevertheless, according to Hastings, this soldier said something like, "Why don't we get some saw teeth and put them on the front of the tank and cut through these hedges?" Most of the soldiers listening laughed or dismissed the idea immediately. It sounded ridiculous. Saw teeth on a tank like some kind of cartoon monster. But Curtis Cullen, sitting quietly in the group, did not laugh. He heard something in the suggestion that others missed. He recognized that beneath the crude phrasing was a mechanically sound principle. If tanks could not climb over hedgerows without exposing their vulnerable undersides, and if they could not punch through the solid earthen banks by brute force, then perhaps they could cut through them, use the tank's own weight and power to drive steel blades through the base of the hedgerow, severing roots and penetrating earth like a plow cutting through tough soil. Cullen began thinking about the problem systematically. He envisioned a set of steel prongs or tusks projecting forward from the tank's hull. These prongs would need to be angled slightly downward so that when the tank drove into a hedgerow, they would bite into the earthen bank at ground level rather than riding up the face of the obstacle. As the tank continued forward with full engine power, the prongs would cut through the roots and earth while the tank's weight kept it level and prevented the dangerous upward tilt that exposed the belly armor. The severed vegetation and earth would be pushed up and over the tank, but the tank itself would drive straight through the breach at ground level. The concept was simple, elegant, and achievable with available technology, but it required the right materials. The prongs needed to be strong enough to penetrate centuries of packed earth and dense root systems. They needed to be heavy enough to hold their position under stress, but not so heavy that they overloaded the tank suspension or reduced its mobility. They needed to be made from high-quality steel that would not bend or break under the enormous forces involved in cutting through a hedgerow. Where could such materials be found in Normandy in July 1944? The answer was literally lying on the beaches where the invasion had taken place 6 weeks earlier. Before D-Day, German engineers had installed thousands upon thousands of obstacles along the Normandy coast, creating a barrier system designed to destroy Allied landing craft before they could reach shore. Among the most common obstacles were devices called Czech hedgehogs, named for their resemblance to the anti-tank obstacles the Czech army had developed before the war. Each hedgehog was constructed from 3 steel I-beams, industrial-grade structural steel about 6 feet long, welded together at angles to form a 6-pointed obstacle that looked somewhat like a giant jack from a children's game. These hedgehogs were supposed to rip open the hulls of landing craft or provide anchor points for mines. In the event, the invasion had bypassed or destroyed most of them. Thousands of Czech hedgehogs now lay scattered along the invasion beaches, having failed to stop the Allied assault. They had been pushed aside by the landing forces, blown up by combat engineers, or simply bypassed. The steel beams, still intact and of excellent quality, were being collected in salvage yards behind the beaches, waiting to be shipped back to England for recycling. Here was exactly what Cullen needed: high-quality structural steel already cut to convenient lengths, available in unlimited quantities. All he needed was permission to experiment and access to welding equipment. Getting approval from his immediate superiors proved surprisingly easy. Officers at every level of the American Army in Normandy were desperate for any solution to the hedgerow problem. When Curtis Cullen approached his company commander with rough sketches and an explanation of his concept, including where he planned to source materials, the captain gave immediate approval. Within 48 hours, Cullen had been given access to a Sherman tank for experiments, welding equipment from the unit, maintenance section, and authorization to organize a work party to retrieve steel beams from a salvage yard near Omaha Beach. The prototype took 3 days to construct. In early July 1944. Cullen and his work party selected 4 sections of steel I-beam from the salvage yard, each approximately 5 feet long and weighing about 100 pounds. They used cutting torches to bevel the forward ends of the beams, creating angled cutting edges that would bite into earth and roots more effectively than blunt ends. They welded a horizontal crossbar to hold the 4 prongs in position, spacing them evenly across the width of the tank's front hull. Then they welded the entire assembly, prongs and crossbar, together to the lower front armor plate of the Sherman, positioning it so the prongs projected forward and angled slightly downward. The result was crude but functional. 4 steel tusks projecting forward from the tank's hull, angled downward at perhaps 10 degrees from horizontal, ready to be driven into a hedgerow. The assembly added about 400 pounds to the tank's weight, not enough to significantly affect performance, but enough to be noticeable. The prongs extended about 4 feet in front of the tank's normal profile, which meant drivers would need to be careful in close-quarters maneuvers. But if the device worked, these minor inconveniences would be more than justified. The first test was conducted on July 11th, 1944, in a field near the town of Isigny-sur-Mer, several miles inland from Omaha Beach. A small group of perhaps 20 soldiers gathered to watch, mostly tankers and officers from Cullen's unit. Most of them expected another failure. They had seen too many proposed solutions to the hedgerow problem, all of which had failed in one way or another. A tank with steel prongs welded to the front seemed unlikely to succeed where explosives and bulldozers had failed. But they were willing to watch, if only to be able to say they had been there when yet another crazy idea fell apart. The test hedgerow was selected carefully. It needed to be representative of typical Norman bockage, not an unusually small or weak example that might give false results. The hedgerow they chose was about 4 feet high at the earthen base, topped with 15 feet of mature vegetation, including oak trees with trunks 4 or 5 inches in diameter. This was an average hedgerow, the kind American tankers encountered dozens of times every day. If Cullen's device could breach this obstacle, it could breach most of the hedgerows in Normandy. The Sherman tank backed up to give itself room to build speed. The driver, a corporal from Pennsylvania, whose name has not been preserved in historical records, was understandably nervous. If the device failed, if the tank bellied up on the hedgerow as so many tanks had before, he and his crew might be the next casualties of the bockage. But he trusted Sergeant Cullen, who had explained the theory carefully and seemed confident it would work. The driver shifted into gear, advanced the throttle, and aimed directly at the hedgerow. 5 miles per hour, 8, 10. The tank hit the hedgerow with the prongs leading. There was a sound like heavy canvas tearing, a deep ripping noise as steel cut through earth and roots. The prongs bit into the earthen bank and penetrated deep. For a moment, it seemed the tank might stall, might be stopped by the resistance of the obstacle. Then the engine roar increased. The driver gave it full throttle. The tank's treads gripped the ground and pushed forward. Earth fountained up and over the tank's hull, blown upward by the force of the breach. Branches snapped, tree trunks splintered, vegetation showered down on the turret and rear deck. And then, less than 5 seconds after impact, the Sherman burst through to the other side of the hedgerow, trailing broken branches and torn roots, but otherwise completely undamaged. The tank had not climbed the obstacle. It had cut through at ground level, exactly as Cullen had predicted. The watching soldiers erupted in cheers and shouts. Some of them were crying, not from sadness, but from relief and hope. For 6 weeks they had watched friends die in futile attempts to breach these obstacles. For 6 weeks they had felt helpless against terrain that seemed unconquerable. Now, suddenly, impossibly, a simple device made from scrap metal had solved the problem. The tankers surrounded Cullen, shaking his hand, pounding his back, thanking him with a fervor that embarrassed the modest sergeant. Officers who had witnessed the test were already calculating implications. If this worked once, it could work again. If one tank could be modified, all tanks could be modified. If the device was as simple and quick to manufacture as it appeared, then perhaps the entire American armor force could be equipped before the planned offensive. But a single successful test, however dramatic, was not enough to transform the course of a military campaign. The device needed to prove itself in repeated trials under various conditions. More tests were conducted over the next 2 days. Different hedgerows, different angles of approach, different speeds. Every test succeeded. The device worked reliably, predictably, safely. Tank crews quickly learned the optimal technique. Approach at 10 to 12 miles per hour. Aim directly at the hedgerow, not at an angle. Give full throttle at impact. The tank would shudder as the prongs bit into earth, but it would drive straight through without climbing or exposing its belly. Breaching time averaged 5 to 8 seconds from impact to emergence on the far side. Word of Cullen's invention spread rapidly through the 2nd Armored Division and beyond. Within 3 days of the first successful test, Major General Edward Brooks, commanding the 2nd Armored Division, had seen reports and requested a formal demonstration. Brooks was a competent, aggressive commander who understood armor tactics and recognized a breakthrough when he saw one. He immediately grasped the significance of Cullen's device and understood that it needed to be demonstrated to the one man whose approval and support could authorize mass production and force-wide implementation. On July 13th, General Brooks sent a message to 1st Army headquarters requesting that Lieutenant General Omar Bradley visit the 2nd Armored Division area for a demonstration of a new hedgerow breaching device. Bradley, buried under reports and complaints about the stalled offensive, was initially skeptical. He had seen proposed solutions before, all of which had failed. But Brooks insisted this was different, and Bradley trusted his division commanders. He agreed to visit the following day, July 14th, 1944, the demonstration that opened this narrative. What happened next was a testament to the flexibility and speed of American military logistics. Bradley issued the orders that would mobilize every ordnance unit, every maintenance depot, every welder in the American sector. Lieutenant Colonel John Madaris, 1st Army Ordnance Officer, was given personal responsibility for the manufacturing program. Within hours, specifications were transmitted by telephone and radio. 4 steel prongs, approximately 5 feet long, made from German beach obstacle steel, beveled cutting edges on the forward ends, crossbar to hold prongs in position. Entire assembly welded to lower front hull of tank. Simple enough that any competent welder could fabricate it. Complex enough that it required skill and care to ensure the welds would hold under combat stress. The raw material was abundant. Salvage yards behind the beaches contained thousands of tons of steel from destroyed German obstacles. Trucks began hauling steel beams to ordnance units across Normandy. The beams arrived in bundles, still covered with rust and barnacles from their time underwater, some still showing damage from explosives or shell fire. Ordnance troops would sort through the beams, selecting those that were straight and undamaged, rejecting any that showed cracks or severe corrosion. The selected beams would be cut to length using acetylene torches, beveled on the ends and set aside for welding. The welding work was brutal. Summer heat in Normandy in July 1944 reached into the 80s and 90s Fahrenheit. Welders worked in heavy leather protective gear, wearing face shields and gloves, manipulating steel beams that weighed over 100 pounds each. The work was done outdoors or in canvas-sheltered areas because there was no time to set up proper workshops. Each device required multiple hours of welding. The 4 prongs had to be welded to the crossbar. The crossbar had to be welded to the tank's hull. Every weld had to be strong enough to withstand the enormous forces generated when the tank drove into a hedgerow at full speed. A weak weld could fail at the moment of impact, potentially causing the tank to belly up on the obstacle, exactly as unmodified tanks did. The ordnance units worked in shifts 24 hours a day. Welders worked 6-hour shifts, then rested, while other crews took over. Acetylene tanks and welding rods had to be trucked in constantly to keep the work going. When one ordnance company ran low on materials, trucks would be dispatched to transfer supplies from units that had excess. The entire system operated with the kind of flexible improvisation that characterized American military logistics at its best. There were no detailed plans, no carefully calculated production schedules. There was only the urgent need to produce as many devices as possible before Operation Cobra launched. Tank crews from combat units would drive their vehicles to the nearest ordnance facility, wait while the device was fabricated and installed, then drive back to their units. Some crews waited 6 or 8 hours, others waited overnight, but they waited because they knew the device might save their lives. Tankers who had lost friends to Panzerfaust fire when tanks bellied up on hedgerows understood that Cullen's device could prevent those deaths. They were willing to wait as long as necessary to get their tanks modified. By July 20th, 5 days before Operation Cobra was scheduled to begin, approximately 300 tanks in First Army had been fitted with Cullen's device. This represented about 15% of American armor in the theater. It was not enough. Bradley wanted more. Medaris pushed production harder. More ordnance units were diverted from other tasks. More welders were pulled from maintenance work and set to manufacturing hedgerow cutters. The pace became frantic, desperate, driven by the knowledge that Operation Cobra was approaching, and every tank without a device was a tank that might be stopped by the blockage. By July the 24th, the day before Operation Cobra launched, approximately 500 devices had been manufactured and installed on American tanks. This represented nearly 60% of the Sherman medium tanks, Stuart light tanks, and M10 tank destroyers that would participate in the offensive. It was not 100%. There had not been enough time, but it was enough. Enough to give American armor the mobility it needed, enough to restore tactical flexibility, enough to break the stalemate. The tanks themselves looked fearsome with their new equipment. The 4 steel prongs projecting from each hull gave the Shermans an aggressive, almost predatory appearance. Soldiers began calling them rhino tanks, drawing the obvious comparison to the horned animals of Africa. Others called them rhinoceros tanks. The names stuck. Within days, everyone in the American Army knew what a rhino tank was. Operation Cobra launched on July 25, 1944, with the most massive aerial bombardment of the entire war. More than 1,500 heavy bombers dropped thousands of tons of explosives on German positions. The bombardment was devastating, but it was the rhino tanks that transformed the breakthrough into a rout. American armor, equipped with Cullen's devices, drove through hedgerow after hedgerow, choosing their own routes, bypassing German strongpoints, exploiting gaps in the disintegrated German defense. For the first time since D-Day, American armor operated with true mobility and freedom of maneuver in the Normandy blockage. The psychological impact on German forces was catastrophic. For 6 weeks, German defenders had relied on the blockage as their primary defensive advantage. Now, suddenly, impossibly, American tanks were appearing from unexpected directions, breaking through hedgerows that Germans had assumed were impassable barriers. The entire German defensive system, carefully constructed over weeks of combat, was rendered obsolete in a single day. By July 28th, American forces had penetrated more than 20 miles beyond the start line. The bocage, the nightmare terrain that had seemed to make sustained offensive operations impossible, was now behind American lines. The liberation of Paris followed on August 25th, just 1 month after Operation Cobra began. The war that had been stalemated in the hedgerows of Normandy was now a race across France toward Germany. Curtis Cullen received the Legion of Merit for his invention. General Omar Bradley personally recommended him for the decoration, praising his contribution to the success of Operation Cobra and noting that his invention had saved countless American lives. Newspapers in the United States picked up the story and transformed Cullen into a minor celebrity. But Curtis Cullen himself, demonstrating the modesty that characterized him throughout his life, refused to take full credit for the invention. In interviews with his commanders and later with journalists, he repeatedly attempted to give credit to the Tennessee soldier whose offhand suggestion had sparked the initial idea. 4 months after his moment of triumph at the July 14th demonstration, Curtis Cullen's war ended in Germany's Hürtgen forest. During combat operations on November 2nd, 1944, Sergeant Cullen stepped on a German anti-personnel mine. The explosion shattered his left leg. He fell and in falling detonated a second mine that severely wounded his right thigh. Surgeons saved his life but could not save his leg. The shattered limb was amputated. His combat service was over. Curtis Cullen returned to the United States in 1945 for continued recovery and rehabilitation. He married Bernice Enright in 1945 in Cranford, though the marriage would later end in divorce in the early 1950s. He settled in New York City and, like millions of other veterans, returned to civilian life and attempted to build a normal existence after years of war. He took a job as a salesman for Schenley Industries, the same liquor distributor that had employed his father for years, and for which Curtis himself had worked before the war. He raised a family. He lived quietly. He rarely spoke about his wartime experiences or his contribution to the Allied victory in France. On January 10th, 1961, just 10 days before leaving office, outgoing President Dwight David Eisenhower delivered remarks. Upon receiving the Hoover Medal Award from the American Society of Mechanical Engineers at the Statler Hilton Hotel in Washington, District of Columbia. In that speech, delivered before an audience of engineers and business leaders, Eisenhower chose to tell Curtis Cullen's story as an example of American innovation and the critical importance of creating organizational systems that allow good ideas to rise from any level, regardless of rank or formal credentials. Eisenhower, who had been Supreme Commander of Allied forces in Europe and had overseen the Normandy invasion from the highest strategic level, said there was a little sergeant. His name was Cullen, and he had an idea, and his idea was that we could fasten knives, great big steel knives, in front of these tanks, and as they came along, they would cut off these banks right at ground level. They would go through on the level keel, would carry with themselves a little bit of camouflage for a while, and this idea was brought to the captain, to the major, to the colonel, and it got high enough that somebody did something about it, and that was General Bradley, and he did it very quickly. Eisenhower continued, emphasizing the broader lesson. The biggest and happiest group, I suppose, in all the Allied armies that night were those that knew that this thing worked. It saved thousands of lives. He went on to note that Cullen had later lost a leg, but was still healthy and working as a salesman in New York the last time Eisenhower had seen him. The speech was Eisenhower's way of emphasizing that good ideas can come from anywhere in an organization, that leaders must create systems that allow innovation from the bottom up, and that sometimes the most important contributions come not from generals or experts, but from ordinary people who see problems clearly and solve them practically. Curtis Grubb Cullen III died on November the 20th, 1963 in Greenwich Village, Manhattan, New York. He was 48 years old. The causes of death are not specified in available historical records. He was buried with military honors in Fairview Cemetery in Westfield, New Jersey, near his hometown of Cranford. He was laid to rest as a veteran of the 102nd Cavalry Group, recipient of the Legion of Merit, Purple Heart, and other decorations. The man whose improvised invention had broken the Normandy stalemate and contributed decisively to the Allied victory in France. A memorial plaque was later placed on a boulder outside the Cranford Municipal Building in New Jersey. commemorating his service and his contribution to the Allied victory. The story of Curtis Cullen is ultimately a story about what happens when ordinary people confront extraordinary challenges and refuse to accept that problems are unsolvable. It is about organizational cultures that value results over credentials and are willing to listen to ideas from any source. It is about the practical American tradition of hands-on problem solving, the belief that any problem can be solved if you think about it clearly enough and are willing to improvise with available materials. It is about the decisive impact that individual initiative can have on the course of history when that initiative is supported by leaders who recognize good ideas and act on them quickly. The steel prongs that Curtis Cullen welded to the front of a Sherman tank in July 1944 broke more than hedgerows. They broke a stalemate that had threatened to turn the greatest amphibious invasion in history into a bloody failure. They broke German confidence in their defensive strategy and their belief that the blockage made them invincible. They broke open the road from Normandy to Paris, from Paris to the Rhine, from the Rhine to Berlin. They broke the last German hope of preventing Allied victory in the West. On that July afternoon, when Omar Bradley watched a Sherman tank crash through a hedgerow that had stopped American advances for 6 weeks, he witnessed a turning point as significant as any major battle. The solution was, as Bradley himself later wrote, absurdly simple. So simple that it had baffled an entire army for more than 5 weeks. But simplicity does not diminish importance. Often the best solutions are simple. Often, the most effective weapons are not the most sophisticated, but merely the ones that solve the immediate problem. Sometimes a sergeant with a welding torch and an open mind accomplishes what generals and engineers, with all their training and resources, cannot. The Rhino tanks rolled through France in the summer and autumn of 1944, their steel prongs cutting through obstacles that had seemed impossible, restoring mobility to American armor, enabling the rapid exploitation that carried Allied armies from Normandy to Germany. They were crude devices, improvised from scrap metal by desperate men, fighting a war that had to be won. They added nothing to the firepower of the tanks they equipped. They required no advanced technology, no exotic materials, no sophisticated manufacturing. They were simply steel prongs welded to the front of tanks. But they worked. And in war, that is all that matters. In war, the weapon that solves the problem is the best weapon, regardless of how simple or sophisticated it might be. Curtis Cullen never sought glory or fame for his invention. He tried repeatedly to share credit with the man whose casual suggestion had sparked his thinking. Though that man's identity remains lost to history, he returned to civilian life after the war and lived quietly, working as a salesman, raising a family, rarely speaking of his wartime service or his role in one of the most important innovations of World War II. But history remembers him. Military historians remember him. The tankers who used his device and survived battles they might otherwise have lost remember him. And the story of his innovation continues to be told to new generations of soldiers and officers as an example of what individual initiative and practical problem-solving can achieve. The greatest weapons are not always the most powerful or the most advanced. Sometimes they are simply the ones that solve the problem at hand, created by ordinary people with extraordinary insight, tested under the most demanding conditions possible, and implemented with the speed and determination that only nations fighting for survival can muster. The story of the Rhino tanks and the sergeant who invented them stands as an enduring testament to the power of innovation, the importance of organizational flexibility, and the decisive impact that individual initiative can have when leaders are wise enough to recognize good ideas and bold enough to act on them immediately. Curtis Cullen's simple welding trick broke the Normandy stalemate, changed the course of World War II, and helped free a continent from tyranny. That is a legacy that deserves to be remembered. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.